Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
There is a lot of debate around what makes someone a senior developer. We talk about how long they've been slinging code, what types of projects they've worked on, and that sort of thing. However, one thing drives a senior developer's work, and that is the developer's mindset when solving certain problems. In this episode, we're going to discuss some common situations you'll deal with as a developer and how your approach to those situations will likely change over the course of your career. But before we get started, Will, what senior decisions have you made this week?
I've just reworked a few small processes that weren't really bad, just Lambda stuff. But I do have another thing I kind of want to ask our audience about. You know, like if you have an ORM, like your typical, entity framework or something like that, you build an expression tree and it goes to the database and pulls the data back, with the where clause that you basically ask for. Do you notice how we don't have something like that for updates? It's always like load this object and then you change the object and then push it. Is there a thing that lets me dynamically build like bulk database operations with expression tree type syntax in my native programming language without loading a domain model up? Because I feel like there should be, and I don't know how I would Google that because everything I've tried has not come up with that. I just wonder if that's a thing, if somebody knows of that. So if somebody knows, email us. Really curious about that. How about you?
Oh, so I started my new job as a lead developer yesterday. Drove up to Nashville to pick up a laptop. It's mostly been meetings and setting up the laptop. They ordered a Mac for me, but I gave me a PC until it arrives. We expected it to be a month or two just because, ordering delays and stuff. But I found out this afternoon that it's going to be ready in a day or two. So that's nice. Works out because I still have to return my old equipment. I would have done that at the same time I got this one, but the person I was told to get in contact with was on vacation last week. So
oops,
it's all right. When I go to pick up my new Mac, I'll just take the old equipment in with me. It was interesting, trying to set stuff up. Oh my goodness. It's a PC. It's running Windows 10. It's slow as Christmas. It is, I don't know what's wrong, but it is just, it's not even that, the specs aren't bad. I don't know
Does
why.
it have a solid state drive?
No.
That's why.
Yeah, makes sense. That's what I was thinking too. No, this is one of the older ones since I wasn't going to be using it. They would have given me one of the new ones if I was going to stick with the PC, but since I'm getting the Mac, they just, gave me one of the older ones and said, "Hey, use this until your Mac arrives." So, which is fine.
Here's a crutch. See how far you can walk.
Yeah.
That happens.
But yeah, pretty much this week has been setting stuff up and going to meetings. We did a watch party this morning for the keynote for MS Build. That was interesting. Yeah, several of my coworkers are big fans of Scott Hanselman, and so I got to tell them the story of going to lunch with him and him apologizing to me. It was right before Blazor came out. And he was so excited about it. He was just pumped up. And we're walking over and he's telling me about it. I'm like, this sounds really cool. He's like, you haven't heard of it? It's like, no,
nope.
It's not something I use. I don't do that kind of development. So it's really fascinating. And he was just in disbelief. He's like, I can't believe it's all over the place. How have you not heard of it? And it wasn't, I didn't think what he said was rude at all. But after lunch, he came up to me and was like, hey, I realized I get really excited and I might have been rude to you. I just want to apologize. I'm like,
and he wasn't.
No, you weren't rude at all. You were I'm like, I do the same thing. I get really excited about stuff. So I completely get it.
He was checking the expiration date on your nerd street cred card. That's all that was. And you were found wanting. Better that he told you than somebody else.
We nerded out on a few other things, but yeah, he was a nice guy. And then I ran into him again. He was a keynote at Codeland in New York when I spoke there. So had a couple of times where I've gotten to meet him. Yeah, he's a cool guy. But it was so funny because I just kind of casually said that because like they were talking about him. Like, oh yeah, he apologized to me once, and then like the whole because we were just having this little conversation on Teams before the build started, and like the whole conversation just stopped, and they're like, "You have to tell us what happened."
Yeah.
So apparently, too, like their director, well, my director now, but because the several members of the team are such big fans, for like the holiday party one year, he was able to get Scott to do a pre-recorded kind of shout out to him video.
Nice.
Yeah, I'm like, that was cool. That's really neat. So like they told me that, I'm like, yeah, that sounds exactly like something he would enjoy doing. From like,
oh yeah,
the times I've met him and like listening to him on other stuff, it's like, yeah, that sounds like him. So that was cool. I had a busy weekend. Our tech team leader at church was out of town. She and her mom, I think they went to St. Louis, but they just did, a mother-daughter trip, which is cool because she's almost never takes any time off. And so she trusted us enough to run the services without her even being in the building, and so that was cool. I was production lead for all 4 services. And when I'm doing something like that, I don't like to wing it.
Yeah.
I like
overplanned.
Oh yes. I spent more time planning for each service than the actual service took. Yeah, it was kind of funny. Then went to a surprise birthday party Saturday too. That was fun. Sunday we had one of our team members call in sick, so I had to start making phone calls like a manager. When you have someone like wake up sick and they call in, I was like, all right, I got to fill your position. So I just like started going down the line calling people. Like 7:00 in the morning, wake up. The funny thing is, like, the first person I called didn't answer. The second one she's one of the teenagers at church, but she's been training on the computers in the sound booth. And I called her and she was like, yeah, I woke up this morning and realized I wasn't scheduled for anything. So I'm really glad you called because I really wanted to serve this morning, but just wasn't on the schedule because I guess they'd been out of town last week, so she didn't get put on the schedule. So she was super pumped to do it. I'm like, nice. That's awesome. That's what we need. So guys, you can get super pumped about your finances, especially when you're using a financial planner.
Lucas Casades is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
Yeah, and just like us, he focuses on helping you not only establish a real plan, but to take action on that plan. His goal is for you to live your best life.
And, to get to that best life, it really comes down to whether or not you can improve your finances with the help of Level Up. The compounding impact of making better financial decisions will easily pay for itself.
One of the really cool things about it is Lucas is a fiduciary for his clients. And what that means is that he's not here to sell you a product, but instead to guide you to a better financial solution.
You can find more resources and learn more about all this at levelupfinancialplanning.com.
We've all worked with them. There is always that one developer who is called a senior developer. They'll tell you that they have 12 years of experience, but after you watch them work for a while, you realize they have only 1 year of experience repeated 12 times. While this has been something that nearly every developer has noticed in their career, if you take the time to really quantify what it means to be a senior developer, it's not really about the number of years of experience you have, but rather about how the years of experience force you to think about your code in a wider context.
If you look at the history of manufacturing and industrial development all the way up to the age of software, you'll realize that the core principle is all about leverage. In the most basic sense, your work as a developer or as someone working on the average industrial project for that matter is going to be centered around trying to make it so that someone else can use your work to be more effective at their job. Essentially, in most development jobs, you don't do the actual work, like the thing that the company gets paid for. You simply make it so that the people that do that work can do so more effectively. This understanding of your job is probably not the one you were taught in school, and it's probably not the one that your tech magazine of choice or your tech website of choice pushes, but it's the truth because it's the one that really matters to your employer. You either do the work yourself or you make the work more efficient, regardless of what they tell you, because they're not hiring you for anything else. If you understand this, it's not as difficult to advance in your job or to get a better job elsewhere. If you don't understand it, getting a better job or advancing in your current job is pretty much impossible unless everybody else is worse, regardless of how long you've been in the industry, because you're not going to be making good decisions.
In this episode, we're going to talk about some common situations that developers face and about different approaches to dealing with these situations, ranked from worst to best. The approaches, not the situations. The idea here is to give you a good example of how your thinking will likely change as you advance. It's not just about knowing more, but is often about having the experience from being burned by less than optimal decisions. However, it isn't entirely necessary to learn it all the hard way. You can learn stuff from other people hitting their head against the wall. You watch someone walk in through a doorway, they bump their head, you know to duck. It's a lot like learning design patterns. You can either learn it the hard way by your own experience or by learning from the experience of others. It's just that instead of trying to reduce complexity and risk from a code only perspective, you're doing so from a broader perspective that includes your code. Now, for each one of these scenarios, we're going to talk about a bad approach, a better approach, and the best approach, and then kind of wrap it up.
Yeah. And I will say this as well on these. Some of the best approaches that I listed here, there's ways that you could probably even make those better in more specific circumstances. So these are fairly broad. I did want to put that in there because there's a reason it is the way it is. So for the first scenario, let's say that your company is considering pulling in a third party component to handle part of the application functionality, assuming that the component works well and has a reasonable cost. And we'll be talking in the aftercast, by the way, about how you calculate whether a cost is reasonable. So there's going to be some math later, but not here.
So a bad approach would be, I don't want to learn how to use that component. I'll just write my own. The problem with this, or the problems with this, are that most things are more complicated than you think, and that ongoing maintenance can be a problem, especially if you're not the one maintaining it.
Yeah, which you never will be, right? Because the
Yeah.
people that will hand roll an external component, trying to simplify it and trying to not do the not admitted here thing, they tend to not be employed here next year. And so somebody else is stuck with it. I had this a few years back dealing with somebody's harebrained logging component that they thought that all it did was write the text files. And like, that's not all a logging component does. It's not all it should do. In fact, we have an episode on that. But it's a trivial implementation thing where people go, well, why would I pull that in? Well, experience will teach you to do better. So a better approach would be to directly integrate the new component into your code and deal with the consequences. You pull it in, you directly talk to it, right? Now, this gives you the advantage of using the new component, but you still face some risk if the component changes, like if it has a major security issue, it has a bug. There was an issue with a logging component I used. I want to say it was Log4Net, where they did something with one of their signing certificates or something where we had to jump through a whole bunch of hoops to switch from the 32-bit version to the 64-bit version.
Mm-hmm.
And it was a lot of pain for our development team because of that. So like if you have that, too tightly integrated, you can get burned by it. It's still better than writing your own because now you're getting burned by all the code versus just the bugs, but it's still a problem.
Yeah. Now, the best approach in this scenario would be to integrate the new component in a way that decouples its implementation from the rest of the application. This lets you get the benefit of using the component, but limits the number of problems the component can cause for the rest of the application. Basically, you want it to be plug and play. So, like, you're working through interfaces, and if that component has an issue, you can literally just extract it and put it back in. Like, for example, you were talking about logging.
Yeah.
I use a logging framework that connects to, because in .NET Core you have like the Microsoft logging that's just like, it's just the interface that goes through, and then I will implement my logging framework of choice with, but throughout the code it's just the Microsoft's logging. So like if I would go to the one place where it says, hey, point to this here, like use this implementation of a logger, I could literally just change that to a different one and not change any of my code.
Right. And that really, really makes it helpful when you get some kind of major problem that comes up. Because basically, as a developer uses better approaches, they start with, trying to reduce costs. In other words, using a component that somebody else has built and, cut the risk. And then they really try to limit systemic risk. So they try to make it so that, hey, if this is a bad decision later, it doesn't blow up in our face. Right. So it's not so much a not committing to a decision as it is, okay, I'm going to make a decision, but I'm going to make it in a way that doesn't allow me to get hurt if I'm wrong.
Yeah, that makes sense. So the next scenario is a critical error has occurred in production, and it is due to an entirely preventable problem. Now, this happens in even the best run organizations, but handling it poorly can mean that an effective team has half their time firefighting.
Yeah, at least.
Yeah.
And the rest of their time isn't peaceful and focused either, right? Because you're always going, okay, well, do I really do this difficult work because production may go down while I'm trying to do it? Or do I, spot patch this spot so that I can, recover if there's a production error? And that, by the way, leads to more production errors in the future. There's like a vicious spiral that goes on there. So a bad approach is to simply spot patch the issue. In other words, the issue that's going on in production, and no further inquiry for an extended period of time. Even if you can quickly fix a problem that occurs every day, this is still a lot of overhead. So a good example of this is somebody is able to sign up on a form and they're able to put in an invalid email address. And then they realize it, and you don't, for some reason, you don't have a way for them to change it. And they go, hey, can you fix my email address? Well, of course you can go in SQL probably, and you can do that. But you're not getting rid of the root problem. So it's going to happen again tomorrow.
Yeah, I saw something like this earlier in my career. It was an old VB.NET application, and every year they had to submit a change request because it was a regulatory thing. They printed off all this stuff to send out to their customers, and they had at the beginning of that a PDF, like it was just attached to the whole thing, but a PDF with the training dates.
Yeah.
And every year, about a month or two before they were supposed to send those out, they had to put in a change request to change out that PDF. All it took the developer was going in and like replacing the old one.
Yeah.
But I was like, okay, it's taking them 2 to 3 weeks to be able to do this job because it has to go through all this process and stuff. And I just told him, like, why? Like, I think I was a junior developer at the time. I'm like, why don't we just code this so that they can enter the dates and it generates this PDF? Because we're generating the PDF from like all this other stuff and just attaching this to the beginning of it.
Yeah.
And at first I we never thought of that. And then I was told, we're going to be replacing that app soon anyway.
Yeah. When somebody says that, my thought is, well, fix it. If it's a quick fix like that, fix it anyway, because soon, maybe after next year.
Yeah.
Now, a better approach is to make it faster to fix a problem, either by providing better diagnostic information or by surfacing functionality in the app to allow a junior developer or even a non-developer to go in and fix the issue. While this reduces the interruptions for the senior developers or the development team in general, there is still a cost for actually fixing issues and a risk of developing larger issues due to mistakes. So, like for instance, with the email situation, if a developer has to go in and do it in SQL, that's bad. It's not as bad if support can go into a back end system and type it in and fix it, but it's still annoying because the user can't fix it.
Yeah. The best approach is to actually take the time to fix the issue in your system if you can, or to explore ways to automatically mitigate the issue. While this may seem obvious, actually getting to the root of some problems can take a lot of investigation and even involve some major system changes to fix it.
Yeah. So, for instance, this week I fixed an issue where we were batching, or well, we were supposed to be batching emails, right? So we, build up a set of, people are all getting the same email and there's thousands of addresses, and we push that to a Lambda that runs through it and, kicks them out. And then, it's getting a timeout. It's like, well, trivial fix would be to increase the timeout. A better fix is to speed up that Lambda, but the best fix is chunk that data set up so that it doesn't ever happen again. But that took some work, right? Because you gotta go in there and find where that is. And I had to change not just that section of code, but because of the way it returned some of its data, I had to kind of trace it up the stack and fix other things all the way up. So the thing that was dispatching that process could go, okay, yeah, it's done. So you'll run into that kind of stuff as you fix it in a better way. So basically the idea here is that as the developer's approach and thought process improves, they're going to first try to take the pressure off their team, right? Because you want to get rid of that. And then they're going to further improve by preventing problems from occurring in order to get rid of the rest of the cost of the problem. So you may, for instance, do a quick fix, which we did, to go in and just increase the timeout. Well, initially we were resending the emails, and then we increased the timeout, and then we did some speed improvements, and then we actually chunked it, so that we could make it so that it wasn't creating as big of a problem because it was thousands of emails.
Yeah, I mean that's the thing with production issues is you have to go in and do like the quick fix to get it back up and running.
Yeah,
and then take your time to, all right, it can be difficult to explain this to management sometimes because I've had these conversations with management where I'm like, yeah, that's a patch. Like I put a Band-Aid over the problem so it doesn't like keep bleeding, but we haven't sewn back together the severed limb yet. We just, stop the bleeding.
What if we just give them a red shirt?
There you go. That works.
Like that's the management solution, right?
Yeah.
It's like, just make it where they don't notice they're bleeding because their shirt's red. Yeah. Don't do that.
Sorry. I thought you were making a Star Trek reference with the red shirt.
No, because then they wouldn't survive at all. Yeah. Sorry.
So the next one is one that we've all faced and you face on a daily basis if you're a JavaScript developer. A new version of your framework comes out with major breaking changes. This does happen every so often and can cause some big disruptions in development. The longer you put off the upgrade, the worse it gets. Do you remember, like before we go into these approaches, do you remember when we were doing some consulting together and they had built the app with Angular 1, like Angular JS, and it was a startup. The owner had heard about Angular 2 and some of the stuff you could do in there. And he's like, I want to switch it all to Angular 2. And like we assessed it and we're like, yeah, no, like that's going to really, you're going to have to rewrite your whole app because there's such a big difference. Yeah. Like we showed him some of the porting options and it didn't work. I was like, now if you want to get that functionality in your application, we can work with your developers to show them how to do that.
Right. But not do it.
Yeah. But not like make that change. I still remember that conversation.
Well, because they weren't even using like a preview version of like Angular JS. It wasn't like the release, official. It was somewhere way down. It was like, hey, this is older than any Angular I've worked on.
Yeah.
And I'm pretty old. So, usually I've run into stuff by the time it's been around a while. So there's two bad approaches here. The first one is never upgrading. And the second one is immediately upgrading. And I would like to suggest that these approaches are almost equally bad.
Mm-hmm.
Because if you never upgrade, then you never upgrade. But if you immediately upgrade, you always immediately upgrade, right? Because people do that repetitively. The first one means that you never get the advantages to be had from upgrading. And if you immediately upgrade, that means you're constantly fighting churn and bugs in early versions of the upgraded framework, especially if it's a Microsoft change, because version one of any of their new dev stuff, you just don't mess with it. Honestly, if you want to get stuff done.
So recently, I guess about a year or two ago, we upgraded everything for TLS 1.2.
Mm-hmm.
I think I talked about it on here. Most of it was just upgrading which .NET framework version we were using, but we had a third party contractor writing an application for us. I think at around this time, and so whereas when we went into our own stuff, we had gone in and changed all, like, not just the main project in the solution, but changed all of them over. They didn't. They only changed the public facing side, like with the controllers and stuff. And so their internal projects were still on the older framework. And we went into to connect that to a service that we had been building to replace an older one, and it didn't work. And turned out that they didn't upgrade that. Yeah. So, I know this isn't exactly on topic, but when you do upgrade, don't just do the bare necessities, like upgrade the whole.
Yeah. At least eventually you might have to do like partial, but you got to get it done eventually. Like, I've known people that are still using like components that they built in classic VB and loading them in .NET. And it's like, guys, it's been long enough that you should have moved this over by now. Just because, when you have to recompile that thing, you got to go find your disk, and you got to get your VM with Windows 2000 on it and go through a bunch of hoops. Like, it's not worth it.
Exactly. So a better approach is to upgrade after waiting for a while. Maybe once others have done so successfully. I did this with Max Big Sur. I waited until a few other people had upgraded, and they're like, "Oh yeah, it works just fine with all the stuff that we use." I'm like, "All right, cool." Unfortunately, I was listening to a UI developer who didn't have to have a Windows VM.
Yeah.
And so, yeah, that caused some tricky issues. But yeah, that was funny. The thing about waiting a bit is it avoids major breaking changes and bugs that can be time wasters, but means that you can't take advantage of major upgrades until many of your competitors already have.
Yeah, and that may or may not be an issue depending on, what you're dealing with. So for instance, if you're doing a website, like an upgrade to .NET Core, great, that's helpful to you. It's probably not going to make a difference on the books, at least not for a good while. Whereas if you're integrating with .NET Core and you're selling a component, then you really can't wait that long. So you do have to think about the business reasons for doing it. But, there's some kind of trade-off there that you need to examine. It's not all just one side or the other. Now, the best approach is to actually have a full set of integration and unit tests, along with solid manual testing procedures, so that you can actually safely upgrade earlier in the cycle. And as a bonus, these practices also make other large-scale refactorings easier to pull off. So, like, if you're switching stuff over to get ready for that upgrade, you can iterate quicker on that because you have automated tests to catch you. Like, that's probably the best solution.
As the developer uses better approaches, they realize that framework upgrades are an excellent test of unit test coverage. That's so true. And other testing processes. They'll use this to their advantage so that other operations, such as large refactorings, are more easily accomplished.
Yeah, I do want to add something to this here because I had a mental note and I didn't actually put it in the outline. Just, this is a secret trick that you use a lot as a senior developer, because you know that your project manager is going to be like, "Oh yeah, we need to do the framework upgrade," right? But they may be against a major refactoring of the app. They may think that's a waste of time. So you use that major upgrade as a way to drive practices that let you do the other one without asking.
Yeah, that actually makes a lot of sense.
Uh huh. A little bit of office politics there, unfortunately, that you occasionally have to do. So the fourth one, a single process within your system is having major performance issues, and it's similar to other processes that you have. While this is common in most software companies to varying degrees, the way you handle it can have really dire business consequences.
Yeah, a bad approach is to simply throw more resources at the problem. While this can work for small things, it isn't a sustainable long term strategy, both due to cost and due to the limits of how much you can actually scale.
Yeah. So I worked on a process early on in my career that sent emails, right? And there was just a little console app that would spin up and go, hey, do we have any emails that need to go out? And it would send them. Well, it's slow because some of these email servers you're talking to don't answer quickly. It's SMTP, whatever. Well, the first thing is why don't we get a faster machine, right? So we can, so it can iterate faster on the ones that aren't slow, and maybe that'll speed it up. Well, that only scales so far, right? And then you just get into trouble, which we did. We actually survived long enough to fix it, but that was our first move. A better approach is to try and improve performance by altering your code so it's more efficient with vertical scaling. So in this particular case, it would be like, hey, I'm going to add more threads so that one of them can't block, essentially. That means that when you get a more powerful machine, you can add more threads. Great, I can get more power. This will give you more room to scale without increasing costs as much, but it only works for a while before you hit some kind of serious limit.
Yeah. So the best approach is to improve performance by altering your code so that it can scale horizontally and run in parallel. This is cool because I was just took a class on parallel programming. What this does is it allows you to scale much further. Not forever, but a lot further along than you're going to get with other approaches. Now, not only does this let you scale further and do it at a lower cost, it can make dynamic scaling easier.
Right. So with that email app, going back to that example, I made it so that it grabbed a batch of emails and it said, hey, these are allocated to me. I'm going to send these. Well, when another one called and said, hey, I need a batch of emails, it didn't get those. It got the next set.
Yeah.
And so we could put 15 servers out there if we wanted to doing that. And, that made it fairly cheap to scale because most of the latency was the network connection to the SMTP server. It wasn't all the email processing that was getting us. And so we could scale out and hit more of those servers at once. And, until we saturated our network connection, which also happened later, it worked pretty well.
Makes sense.
You'll notice, though, as you use better approaches, the amount of time that you have before you run into a scaling issue increases. So your mean time between critical system failures due to load gets longer. And that's kind of what you want. The idea here is to stop fixing problems in the short term when you can and fix them in the longer term instead.
So the next scenario is new developers on your team consistently have trouble getting to the point of being productive. Your onboarding process is a window into how well your development team works in general. If it takes weeks to even get going, you have a problem. And that's interesting because I am in the middle of the onboarding process right now. And it's kind of cool. We're actually starting a new project next week. So I'm doing like a lot of meet and greets, a lot of meetings, paperwork, stuff like that this week. Next week, jump right into it with product, like with the not product launch, but the project launch. That's what I'm looking for. And so starting on a new project with a new team, it's going to be really cool. And so it's interesting because we're probably not going to get to code for a couple of weeks because it's, again, a new project.
Yeah.
So like that, but what it's allowed is for a lot of that onboarding process to be kind of spread out rather than trying to do it in just a few days.
Yeah. And onboarding is tricky depending on the organization because you may actually have a lot of stuff going on and it takes a while, or there's regulatory stuff or security stuff or whatever. And in my current job, I think the second day or maybe the third, I actually pushed code that went to production, and went through the entire, PR build cycle and, all that fun stuff. It wasn't anything, super substantial. It was like setting up infrastructure for Lambdas. You're putting in all the crap in the YAML that you got to have, and they tell you what to put. But, we were able to spin that up and onboard fairly quick. But a lot of companies can't do this. So a bad approach to this is to, simply pull a senior developer out of active development and have them sit with the junior dev or the new dev as it is until they get the environment working. Now, this might be the way that you do it in the short term, especially as you're starting up where you don't have documentation or everything's changed, or you've got the one developer that was working on this thing and is one of the partners in the company is now actually hiring help, and they don't have any plan to do this. So they're figuring out the hard way. This is not sustainable as a long-term strategy. In particular, you typically hire when you need more help, or actually you tend to hire well after you need more help, because you make the decision to hire when you go, hey, we need help. But that doesn't mean somebody comes in tomorrow. So you're probably weeks or months after that. So you really can't distract the senior developer when they're already overloaded. That's not good.
A better approach is to document the steps required to set up a new user and have the new hire follow them. This keeps that senior developer from being tied up, getting things working for a new hire, but it's still going to cause a lot of interruptions when setting up a new environment. Especially I've been doing that yesterday and today, and our architect is the one who's been helping me. And so we had about an hour and a half call yesterday setting stuff up, and then he gave me some stuff to do. I started working on it. They have a lot of really good, most everything is documented, and it's just, hey, go do this, follow these instructions. But he was just making sure I was using this, all the same tools and stuff, and had them set up if I ran into any problems. So
the best approach, though, is to have a repeatable automated process for setting up an environment for a new user. Now, this takes a lot of time to get going. It's not as bad as it used to be, but it still takes a minute. But it does mean that you can quickly spin up a new environment. This also means that it's easier to keep environment configurations synchronized. And this gets rid of a lot of uncertainty in the entire development process by eliminating variables. By the way, this is something you're going to want to do for your server environments as well, because if you're spinning up a EC2 instance, you kind of want all those pieces where you can do it again when you need to scale out, instead of manually copying and pasting and trying to do serverless deploys. That's not a whole lot of fun. I've worked in a couple of environments where developers had done stuff they had added stuff to their system path, right? And then their code goes in and goes, oh, I'm just going to shell execute to do this thing that I've got to do, which is great if you have that path variable. But when it goes onto another developer's machine and they try to run it, now it doesn't work. And it's okay, let me look through the code and try to find what they're doing here. And then, oh, here's the problem. And you're looking at an hour of diagnostics every time something like that happens. So if you have a repeatable way of setting up an environment, that gets rid of a lot of this. Again, assuming that you maintain that repeatable way and you push things out.
Yeah, and it can get tricky too when you're a larger organization and you have just the stuff you put on there, an image or something to go on there, but it's got to be generic because it may be accounting that gets this, you don't know who's going to get it. And so you still have to have the individuals put their stuff on there based on what they're doing too.
Yeah. And you may want to do something like Docker, honestly.
Yeah.
I mean, that's the kind of problem that they're trying to solve with this, is because configuration, has gotten to be pretty much nightmare level, and has been for a very long time. So you're going to definitely want a better approach.
So as developers use smarter tactics, they're going to reduce the workload placed on existing developers when hiring new ones, because it allows the team to scale. Eventually, they'll shift from vertical team scaling strategies like documented onboarding to horizontal ones, automated new environment creation, to allow the team to scale more easily and consistently.
So the next issue that comes up, and you'll hear this all the time, you have regular failures after hours on certain processes. Now, this is going to happen at some level in almost every organization. In fact, I just saw the error channel blow up about 15 minutes ago on my work laptop. It's like right in my field of view over here. So that happens, but it's a really bad sign when it happens frequently and people have to stop to address it. Not only does this destroy work life balance for the team, but the fatigue and distraction that it causes can often result in even more errors along with employee turnover. Because if you're getting interrupted at night at home and you never can have a life because of job stuff, you change jobs.
So, a bad approach to this is to have an on call routine. And this may be necessary in the short term. In the long term, it makes working for your company a negative experience, and you'll lose the more capable members of your development team for somewhere that doesn't suck, according to what Will wrote.
Yeah, I mean, it this is something that's actually pretty common, right? Like this is how you create a Dead Sea effect is these kind of things. So what's a better approach than that? Well, a better approach is to use, some of your enterprise application patterns to implement things like retries, incremental backoffs. Basically, the idea here is to reduce the frequency of these errors. So, like the first time it blows up, it doesn't send an error. It waits a minute, tries again, and goes on through.
Hmm.
Because a little bit of slowness versus the system outage is kind of preferable. It makes it a little bit easier to kind of to recover from these issues by reducing the number of after hour support issues, assuming that your issues are transient architectural problems and not deep business issues. So for instance, a database connection problem versus, oh well, our internal system just is being dumb and crashes regularly. Like that's not a good example, but not being able to contact the database server is something that everybody deals with at some point.
So, the best approach is to actually do a root cause analysis on the issue you're facing, fix them where possible, and make it possible for non development staff to fix them where it isn't. The idea here is to get rid of the problem to the degree possible and put the remainder of it on lower cost resources where you can't get rid of it.
And obviously you prefer the first one because it's still miserable, for support people at night. But a lot of times companies will have, overseas operations that kind of deal with this sort of stuff anyway. And it's part of their job and those people are already there. So, even if you could just shift it to them where it doesn't increase their workload much, that's better than, a developer sitting at home at 9 o'clock at night and getting a phone call and having to drop everything. And, as you start using better practices, you're going to try to deal with after hour support interruptions by minimizing them as much as you can. You're never going to prevent them entirely, but when you lower the cost of dealing with them, that makes it, it makes it less visible to management as a problem. And it also makes it more likely that you can deal with it in a way that it's not visible to the customer. Odds are good that the cheapest way of dealing with a problem doesn't require development involvement to a large degree, or it shouldn't.
That's why you have support staff like who like their job is to answer the phones. That's what they do, and you want to make it so that they can do their job better so that they don't have to come to you when they get a call and they're like, I don't know what's going on here.
Yeah, well, and the other thing too is they're also logging all this stuff in a way that developers usually aren't. And so if something is a continual problem, it's better to have support deal with it, even in the absence of cost, because support people will actually document that they dealt with it. And that you go, hey, this happened 58 times last month. Like, we've got to fix this. Whereas developers go, it happens a lot, man. I don't know.
Yeah.
Because we never do that.
So, speaking of support personnel, the next scenario is support personnel routinely interrupt developers to ask the same questions over and over again. Could also be QA doing that. I've had that problem too. While this can be an indicator of poor support training, it's often a better signal of deeper process issues that need to be resolved.
Yeah. So a bad approach to this is what a former employer of mine wanted to do, which was just to segregate the development team so that support could never interrupt them. Unless you're actually hiring and training support people perfectly, this is probably not really sustainable. basically it's a deeply flawed process that assumes that the support person or the ability of support to contact development is a problem. Really what should happen is support should only be approaching development when they don't have other options. And so when you segregate development from support, that simply means that support has no support, which ultimately means your users have no support. Now, a better approach is to document the problem and how to fix it, each time that support contacts development. Do this in a wiki. While this should reduce the frequency with which development is tasked with support issues, it doesn't solve all the problems. It also means that any problems that do occur will do so in a naturally interruptive manner. So you can think of a wiki as sort of a vertical scaling strategy for your organization. As you scale the teams, yes, this is necessary to make it so that there are fewer interruptions, but it doesn't get rid of all of them. But again, it's still better.
The best approach is to build automated ways that support can use to resolve the issues they encounter, even if those issues are otherwise too complicated to handle on their own. While this approach requires more development resources, it also tends to free up development resources from random interruptions, which are actually worse than giving them saying, hey, we need you for a couple of weeks to work on this. Because if you're getting interrupted several times a day, you're wasting more than a couple of weeks a year.
Oh, yeah, easy.
Yeah. And you can see the aftercast for discussion of how to determine whether an automated fix is worth the trouble.
Yeah, the real deal here is that support is a first-class user of your application, and dealing with support issues is a large part of your role as a developer, even if nobody told you that. As your approach improves, you should realize that your support personnel are your first line of defense against larger application problems, and you should do your best to support them. If your support team is adequately supported, your users will be happy, making it easier for you to continue doing your job.
So the next scenario is one of your API endpoints is getting attacked, and this attack is degrading system performance across the board. As your application gets attention on the internet, this becomes more likely. If your API responses take more time to generate than the requests that cause them to occur, it's just a matter of time before an attack occurs that degrades your system performance using this endpoint.
Yeah, a bad approach here is to simply block access to the offending endpoint while the attack is occurring and then turn it back on later. And, I can't say that that's never happened with, for instance, the podcast website and the login screen on it. HD access self-defense there. This is a short-term fix, but it really can't be a long-term fix because it allows third parties to control whether your application is available completely to the people that are paying for it or not.
Now, a better approach is to defer workloads like this and handle them in a background process so that performance degradation is not as immediately obvious to your users. What this does is it makes it harder to accomplish a denial of service attack on your systems. An attacker, though, can substantially raise your costs in this manner, even if your users don't notice.
Yeah, so like a classic example of this is, you're delegating stuff out to, AWS, for instance. Well, okay, yeah, they can't attack as quickly and, make your web app really unresponsive for all your users by, saturating the thread pool in the web server at least as quickly as they could before. But they can still, those Lambda invocations are not free. And, whatever resources they use there, that can really hurt you, especially if you auto scale and you don't have a cap on it, which, actually the cap is whatever numbers in your bank account at that point. But so like you get hurt more easy that way, but it's not as bad. The best approach is to make sure that only paying authenticated users can kick off a process that costs resources, especially if there is an asymmetry between the effort required to start such a process and the effort required to fulfill such a process. And, it's even better if you can make the user pay, a per click charge when they do stuff like this. That way, if they do a denial of service attack and they're paying, at least theoretically, you're getting paid. It raises the barrier to entry Of course, then you have problems with things like them using bad credit cards and those kind of issues. But it does make it more complex for them.
Yeah, that's why you use a credit card service. Let them.
Oh yeah,
Yeah, don't deal with that on your own. As developers use better strategies, a lot of security issues related to scaling will be more properly understood as a potential revenue opportunity. A lot of attacks where people are misusing your system are not much more than unaddressed business opportunities.
yeah. You used to see this a lot more back in the day than you do now, but where somebody would, like maybe they would have a JSON formatter, for instance, and you got somebody that writes a program that pushes a bunch of JSON at it and gets it formatted and pulls it back. And it's like, well, that's not an official use of the system, but if people are hitting it for that reason, why don't I stand up a service where they can do that and pay me? Like that's a question a developer should be asking at that point, not how do I stop it from happening?
Mhm. So, the last scenario we're going to talk about is regular development actions, such as build, pull requests, deployments, all those sorts of things, take an excessive amount of time and configuration. While automatic build deploy systems are a huge productivity boost, they do take a lot of effort to set up properly. And frequently, these processes are set up and left in a good enough state that allows developers to do their own work while being a little cumbersome.
Yeah. So a bad solution to this is to simply add documentation. You notice how this isn't the middle tier. This is the worst tier because you have developers writing documentation for other developers. And that's almost never good. Just like as a rule that we don't do this well as an industry, don't lean on that. Now, this can help reduce the headaches for new developers, but it doesn't really solve the issue. If there's a lot of manual configuration required every time you want to, for instance, create a feature branch or do a pull request or deploy or whatever, it becomes a burden for the development team to get it right consistently. Additionally, it makes it harder to change because you now have to communicate every change to the team and then make sure they follow those new guidelines because they were doing this mind-numbing thing over and over again before, and now they don't remember what they're doing.
A better solution is to have sensible defaults set up in your systems that do as much as possible to make sure that developers follow standards with automatic checks to catch them if they mess up. While this is better than the first option, it doesn't entirely remove the burden from the development team, and it requires training after every change to the process.
Yeah. So a great example of this is doing something like environment variables and setting them to something dumb that your script checks for and goes, "Hey, they didn't do this," and stops the build. That's better than it trying to go through and screwing everything up, but it's still that's not hot. The best solution is to either use built-in tools or to build your own tools that set up default settings automatically on your development process. At my work, we've actually got an app that links our issue tracker with Azure DevOps, and so I can say, "Here's the ticket I'm working on. Create the branch. Do the feature branch up in AWS or not AWS in Azure, and I can pull that branch down. It does all the settings, like all the build validation scripts, all that stuff. It's in there, and I don't have to do that every time, which is a lot of crap you have to do. The ideal solution to developer configuration headaches is to make sure that they aren't a problem for the average developer. They can be a problem for somebody that's deeply interested in that thing, and that's fine, but don't do it to normies.
While external facing software is probably what you are being paid to develop, don't neglect the development of developer facing software that can make the rest of your processes easier. That's what I was working at my previous job was some like enterprise level stuff. And that's kind of what I prefer to work on.
Yeah.
Really, because I like building those internal processes. Remember that development is all about creating leverage in regards to real world processes. If you are creating leverage regarding important development processes, this can potentially translate into a lot of real world leverage.
For instance, if you're doing code generation, helps a lot. The way you think as a developer determines how far along you really are. There are plenty of beginner developers that have the mindset of a senior developer, a lot of times without all the required practice. So they're still juniors, but they're way better juniors. Just as there are tons of senior developers who have very neophyte understandings at best of what they're actually doing. While hiring managers often view a senior developer as someone with years of experience, this really is a secondary understanding of the type of leverage that a senior developer can and should be able to provide. If you can provide this sort of value as a junior or mid-level developer, you will be well ahead of the other people at your level when it comes time for promotions, especially. Ultimately, it all comes down to an understanding of how developers can provide leverage to their employers. And that pretty much wraps us up. Beach, what do you have this week for us for tricks of the trade?
So the stuff we talked about in this episode, while we were talking about very specific things for development, doesn't only apply to your role as a developer. As with everything you do, there are going to be a lot of different approaches you can take. And so creating a process for assessing how you address various situations is going to help you out. You can look at situations in your life outside of work and use the same concepts that we talked about here. Obviously, not the same implementation, but some of the same concepts can be applied. Basically, what I'm getting at here is that you want to act on information, not react to situations. So plan out your approach to things. Like, if you notice, a lot of the bad solutions were like they worked in the short term because they were reactions.
Yeah.
The better solutions were partially thought out actions. They're a little reactive, a little thought out. But the best solution was something that, all right, we've assessed the situation. We're acting on this, not reacting to this. You can start this by doing retrospectives on your own life. You know, some of the better and best solutions up there come from, hey, we patched it. We did the bad solution. We patched it. We got it working, but that's not going to last. In the retro, you talk about, all right, what could we do better? How can we fix it? And you can do that to your life too. Like, hey, I handled this situation, but I could have done it better. What could I have done better? And try to do that the next time around. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.